So today we are going to discuss the trial questions in paper 2 for Penang set 1. No? Okay. So we look into the structure questions first. Okay, question 1. Table shows the three substances and their respective chemical formulae. So bromine, lead, and then lead to bromide. So given to you the chemical formula. So use the information in the table, answer the following question. What substance which exists as an atom? Okay. Formula then be very simple. So which one will be the atom? It's the lead, no? Lead. Okay, atom. It's a single atom, a single particle. So it be lead. So this one you can use the pen or you can use the formula. But you have to be careful. Sometimes the question will say, state the name. So if we look into the step, you can use the name or you can use the formula. But if the question says state the name, you must use the name. You cannot use the formula. Okay, but this one should be no problem. Both are accepted. Okay, number 2, write the ionic formula for the substance in the A1. So lead. So what is the ionic formula? Meaning that when it forms the ions. So what is the formula? The charge. Actually, if you want, you also can write lead 4 because it has Pb4 positive also. But in the SPM level, it is not that popular. So we can write Pb2 plus. Okay. Next, which substance has the lowest melting point? So melting point here, okay, it will be the covalent compound, the molecules here, because it has the weak van der Waals force. Van der Waals force. So it's a problem. Okay, then plus if the question change, which substance has the highest melting point among these three? So which one is highest? Has the highest melting point or boiling point? What is the answer? If the question change, is it lead to about Felix and Shannon? What do you think? Among these three, which one has the highest lead to bromide? Shannon? Sam. Okay. This one you have to be careful. If highest melting point, it should be the lead. Why? Because lead, it has the metallic bond. It's strongest. So if among these three, okay, so this one highest melting point. Second one, then only goes with the ionic bond. Okay, it has an electrostatic force. Okay, then the lowest it will be the covalent compound with van der Waals force. Okay, why? Normally the question will ask you to compare the ionic and covalent only, okay. But remember, if it has the metallic bond, any metals, then it has a metallic bond, then it will be the highest among these three. What is the value? .373 melting point. How about the lead? It should be highest metal. Yeah, we check again. Okay, but theoretical, the metallic bond will be, it should be the highest. Okay, I'll check again. Okay, thank you. Now internet information a lot now, right? We can search it anytime. Okay, Okay, now what is the state of metal of bromine at room temperature? Okay, so here state of metal, or you will see physical state. Okay, so what is the answer for bromine at room temperature? Is it gas or liquid? Bromine. How about the other two? Normally, when we read or normally we call it bromine gas or bromine water. bromine water, right? So it's a bit liquid, actually, or gas also can. Why? Because it can vaporize easily. But normally we call it bromine water lah. Previously we have the diffusion rate. Now no more lah. When we put the bromine water there, and then it can vaporize to gas. So normally we say it is bromine water. If we store it in the bottle, it will be in the liquid form. Liquid form. But if you write liquid gas, means it vaporized already. I would suggest you to write the liquid now. Okay, next. Lead-2 bromide can conduct electricity in the molten state. So give a reason. So in the molten state, okay, what is your answer? It has freely moving ions. I would like you to put in this one. There is one here that says we don't encourage the students to write the free. Okay, free like free of charge. We encourage the student write freely moving ions. Okay, so remember this. Bergerak bebas. Because free in BM, it has a meaning like percuma, right? It's free. Okay. But in the real one, we want to mention is the bebas bergerak, bukan percuma lah. Okay. So freely moving ions. Okay, everybody take note on this. Okay, very good. Okay, number 2. Okay, name the structural formula of natural rubber based on the IUPAC nomenclature. Okay, so this one. Okay, so for this one, you don't afraid when you see this one. Don't be afraid. Actually, just the naming system. So what is the name for this natural rubber? Okay, 2-methyl. Okay, built 1,3 diene. Okay, natural rubber. Okay. Formula for the. We need to put in the. Okay, Dong Kyung, you mentioned about 2-methyl built 1,3 diene. This is for monomer. Monomer. Okay. This is the monomer, right? If natural rubber, okay, I think your answer should be correct also. Poly means the polymers already, okay. So your answer should be correct. Okay. 2-methyl built 1,3 diene. Okay, now the structural molecular structure for the natural rubber. Okay, so with the polymer, right? So you can see, okay, the double bond, 2 double bond break already, to form these 2 new single bond. But the double bond it changed to one single only one carbon-carbon double bond here. Okay, this one times n should be times n. Okay, yes. This is the natural rubber now. Okay, now we look into this question for B. Diagram shows the molecular structure for natural rubber after undergoing a process to enhance its property. Okay, so if you see all these sulfur, double sulfur like this, this one, we call this is the disulfur linkage, right? Okay, so what is the process? Okay, vulcanization. Okay, vulcanization, no? Okay, explain how the process of vulcanization improves the elasticity properties of the natural rubber. Okay, so elasticity, what is the definition, class? Along here already, we revise again. What is the meaning of elasticity? Hmm? Okay, ability to return to its original shape or original length. Okay, is one. Okay, ability to return to its original shape or length. Okay, it has another one beside this one. Easy to stretch or not? Hmm? Is it very easy to stretch it? Not easy, yeah? Okay, difficult to be stretched. Okay. Compared to the unvulcanized rubber. Yeah. If natural rubber now without undergoes the vulcanization. So it's very if more difficult to be stretched. And then if you stretch it, and then it can be it is able to return to its original shape or like okay. So we call it is more elastic now, more elastic. Okay. Now based on these two, then we can explain how the vulcanization make it difficult to be stretched and then able to return to its original shape or length. Okay, so the presence of the sulfur crosslinks between the rubber molecules because of these sulfur crosslinks, it has then it will pull the change back to the original position when the vulcanized rubber is stretched and released. Okay, this one is the answer for it. Maybe you can use the different sentence to explain as long as you have the point or you have the key points here. Okay, same meaning, same meaning. Okay. Now number 3. Okay, diagram shows the combination of cellulose and lignin. Lignin will produce a composite. Composite. So state the function of this lignin. Okay. So it can becomes the matrix substance. Matrix substance. Okay, next. Now, fiber optics is a composite material. State the substance in the fiber substances in fiber optic and its advantage. So, what are the substances in fiber optic? Then plastic. What else? Plastic and fiber, glass fiber. Glass fiber. Okay. Plastic and glass fiber. Okay. And the advantage of this fiber optic, okay, it is flexible. It has high compression strength. Okay, flexible or any suitable answer accepted also. Okay, you can refer to the textbook or reference. Okay, now the pyramid of Giza in Egypt are believed to have been built out of ceramic. Ceramic are solid consisting of non-organic material and non-metallic materials. So it is produced through the process of formation and hardening using the heating method at high temperatures. Okay, so two types of ceramic. Okay, so what are the two type of ceramic class? Traditional and advanced. Yes, two types. Traditional ceramic and then advanced ceramic. Okay, two types. Okay, now based on your answer, what type of ceramic is suitable to manufacture above substance? Pottery, brick, ball. So these three, which one is suitable? Traditional or advanced? Should be traditional, huh? Traditional. Okay. Because this one is the normal one now. Okay. Number 4, table shows the empirical formula and the molecular formula for two compounds. Now state the meaning of empirical formula. Okay. So for this one, I directly show it to you. Okay. Chemical formula that shows the simplest ratio of atoms of each element. Okay. Simplest ratio of atoms of each element in the compound. So remember, don't miss out. Don't miss any points for these two. And now write the empirical formula for compound P. So what is the empirical formula? So simplest ratio for atoms for each element here. We have carbon, we have hydrogen. So this one should be CH2, right? Okay, CH2. Okay, this one very simple now. Okay, now when compound Q is heated strongly, it will decompose to form the zinc oxide, oxygen, and nitrogen gas. So write a balanced chemical equation for the decomposition of compound Q. Okay, so decomposition refer to heat. But this one, remember, if decomposition, no need to pass oxygen. No need. If you want to add in plus oxygen, then your equation won't be able to be balanced. So just remember. So no need to plus oxygen. So it will decompose on it. So it forms the zinc oxide, nitrogen dioxide, and oxygen. So first mark is for the formula, all correct. 1 mark. The second mark is for the balancing. Okay. If one of the formula wrong, then 0 mark already. You won't be able to balance. Okay, huh? Okay. Now, if this one, the compound Q is heated, calculate the volume of the nitrogen dioxide gas produced at room condition. Okay, so 3 marks. This one, I let you try to calculate if you haven't. Okay, already calculated. Australia get 2.4 cubic decimeter. Yeah. Yeah, that's also got the same answer. 24 or 2.4. Now you have to double check. Always check back, especially the calculation, the decimal points. So which one is correct? Dong Kyung and then Felix and Shan. What is your answer? Okay, so now check that. Okay, so if we equation, I just want to show it to you here. Okay, first we calculate the number of mole. Okay, given to you the mole already. So we do the mole comparison 2 to 4. If 0.5, meaning that the nitrogen dioxide will double, we 1.0. So volume 1 times 4, so the 24 cubic decimeter or 2,400 cubic centimeter. You can refer, you can make this answer on this answer. Okay, it's 24 cubic decimeter. Okay, unit must be taken correctly. Okay, now question number 5. A table shows electrical conductivity and the melting point of RST. Yeah. So you see here, this is R. You see, it can conduct electricity in solid, molten states. Okay, and then melting point is 660 degrees Celsius. S only can conduct electricity in the molten state, 192. Cannot conduct electricity in both solid and molten state. Okay, so this one come back to the concept just now. So which one is the covalent compound plus RST T? Okay. So we know this is a covalent, lowest melting point, right? And then conduct this heat. So this one is a covalent compound. Okay. Now which one is the ionic compound? Okay. Then R is the metal. Yes, this one is metal. Okay, so that's why just now I mentioned the metals, it has the metallic bond is the strongest. So it always has the highest melting point. Okay, now set the type of bond for substance R, S, and T. So R is metallic, right? And then S will be ionic bond, and then T will be the covalent bond. Okay, so here you always need to be careful. The question asks you the bonds, you write the bond. Okay, you don't write the compound. Okay, so remember, if you don't want to be safe, you just write metallic, ionic, and then covalent. Okay, no need to write bond, no need to write compound. You don't care it is asking you the compound or the bond. You just write metallic and then ionic. Okay, to be safe. But always check first if you want to write bond or compound. Okay. Now state how the bond is formed in the substance S. S is what? S is ionic, right? So how the bond is formed? Donate and receive of the electrons. Okay, correct. Or you can write electron transfer. Both can be accepted. Your answer is correct also. You can write donate and receive of electrons or electron transfer. Same meaning. Okay, does substance T soluble in water? Yes or no? No. No. Okay, why? Explain your answer. No. Okay, it is soluble in organic solvent. Okay, covalent compounds are neutral or do not carry any charge, and it is soluble in organic solvent. Organic compound or organic solvents. Okay, but somehow the question normally will ask you the electrical conductivity and then melting and boiling point. Okay. Seldom the question will ask you the solubility. Okay. Now, why does the wet finger help to turn the page of a book? Explain your answer. Okay, so this one, what is the concept you need to mention? You need to focus to what type of bond? Yes, hydrogen bond. So, oxygen atom in the water molecule, it has high electronegativity. So force of attraction between the water molecule and the hydrogen atoms in the cellulose or paper molecule form the hydrogen bond. Okay, so you need to mention, explain based on the hydrogen bond. Okay, so you have for hydrogen bonds that there are few more application like you want to your hair, right? Okay, your hair also the same. When it is wet or it is very difficult, right? To comb it, right? Okay, so books is another one. Okay. What else is the application for this hydrogen bond? Any more? Okay, the cloth, huh? Yes, the cloth. Correct. Okay. Now number 6. Okay, regarding the heat of reaction now. So there are 4 types of heat of reaction: combustion, precipitation, displacement, and neutralization. So every year in the SPM, at least 2 of these heat of reaction will be asked. Okay, so you have to get ready for all of these heat of reaction. So initial temperature 29, highest temperature 33. So it's copper 2 nitrate and then iron powder. So what is this reaction, class? What is this reaction? Displacement. So it is talking about this heat of displacement. Heat of displacement. Okay. So what is the meaning of heat of displacement for this experiment? So this one, you put in the exact matter with the solution. Okay. So total energy release or change when 1 mole of copper is displaced from copper 2 sulfate solution by iron. Okay, because we want to focus to this experiment. So by iron, okay, copper is displaced from copper 2 sulfate solution. Okay. Now, why does the iron in the form of powder is used in this experiment? Why we use the powder form? This one related to the rate of reaction actually. Iron powder used to complete the reaction in the shortest time, or to increase the rate of reaction. Okay, shortest time. Okay, now why plastic cup is used in this experiment? Neutralization also the same, neutralization, displacement, and then neutralization, displacement, precipitation also the same. Okay, so standard answer, right? To reduce the heat loss. Don't use prevent. Don't write prevent. Reduce the heat loss to the surrounding. Okay, enough. If you want to mention it because plastic is a heat insulator, also can. But this one must have to reduce the heat loss to the surrounding. Okay. Set one observation in this experiment. Okay. So this one you can write the thermometer reading increase. Okay. Because here you see the temperature is increased already, right? Okay. Beside this, if you can, you write the color change. The blue solution turns to green. Okay. And then, or you can write brown precipitate is formed. Okay. Or plastic cup feel warms. Okay. All this you can write. Green is okay already. If you can write green. Blue solution turns to green. Okay, why? Why it turns to green? This is blue, right? This is copper 2 is blue color. So it forms a green here. This is green color. The solution, right? Then this is a brown solid, brown solid. Okay. This one you can write solid, And normally for this one, it won't change to iron 3, it will change to iron 2. Okay. Okay, now this one for calculation. So have you calculated this one? The heat release? Is it delta H? No. Okay. Total heat release. If you want to find the delta H, you would write heat of what? Heat of reaction or heat release when 1 mole of what? You will see per mole. Okay. So this one total heat release, only the Q. So what is your answer? 840 joule. Correct, huh? 840 joule J. Okay. Now the number of mole, MV over 1000. So you get 0.05 mole. Okay. Then finally is delta H. What is your delta H? Heat of precipitation. What is the heat, delta H? Okay, so it depends to you want to use a kilojoule or you want to use a joule. Okay, so if you want to use a kilojoule, it will be negative 16.8 kilojoule per mole. If you use a joule, it will be 16,800 joule per mole. Okay, both are correct. Both are correct. Okay, but you need to put in the negative sign to show it is an exothermic reaction. Exothermic. Okay. Question 7. A table shows the information of 3 different food additives, PQR. Okay. So added to a low-calorie soft drinks to sweeten it for the consumption of the diabetic patients. For P, Q, add to fresh meat to preserve it and make it look fresh. R, add to the pickle, chili, or mango pickles. Okay. So suggest the name for the food additives, P, Q, and R. So what is the answer, class? Can we try this? So P, aspartame. Any other suggestion? Okay. Sorbitol. Okay. Aspartame. Stevia. Let me check. This one got PM and PI version. So any one of these. Okay, aspartame, sorbitol, or stevia. Okay. Then Q. That's your answer for Q. It's a preservative, right? Okay. Benzoic acid, what else? MSG. MSG is a flavoring, no? So it is more to the it's a fresh meat to preserve it and make it look fresh. Okay, sodium chloride, sodium nitrate now, sodium nitrate or sodium nitrate, these two. Okay, we seldom use the sodium chloride. If you use the sodium chloride, it becomes very salty already. You get what I mean? And then benzoic acid also, Dongkyong. These two, it can become the preservative, not wrong, but in terms of the test later, you use the it is a weak acid, then it becomes acidic, sour test already. Then sodium chloride, yes, it can become a preservative, but later it becomes very salty. Okay, then so sodium nitrate and sodium nitrate of these two, it won't You won't change the test a lot, huh? Okay, no? Okay, next R. What is R? So R, vinegar, vinegar. This one is okay, chuka, chuka. Okay, next, state the advantage and disadvantage about the use of food additives in our daily life. So advantage for food additives, it can prolong the lifespan, enhance the appearance, taste the food, okay, last longer, yes, can, advantage. Huh? Disadvantage, food additives, it can cause the adverse or side effect or cancer or food poisoning or allergy. So disadvantage, I will encourage you to write the allergy, huh? Because a lot of food additives, it will cause allergy. Huh? Okay, cancer, if you use a lot now, right? A lot of these always eat the food additives like MSG, looks eat for a few very long time now. Okay, then it will cause the cancer now. Okay, so any one, one advantage, one disadvantage. Okay. Now, why substance are added to the chili pickle and mango pickles? Okay, so it is vinegar, right? Okay, make it last longer or provides an acidic conditioner to prevent the bacteria growth. Okay. Now, R is a weak acid. Describe the chemical test to confirm it. Chemical test. Don't use indicator like litmus paper. Okay. No, don't use indicator. So that's how to confirm the weak acid. Okay, you put in the magnesium ribbon. Okay, then this is action, huh? Okay, you can insert or put in a magnesium ribbon into the R. Okay, then if you want to mention about the chemical test, action and then observation. So what can you observe? Effervescence occur. Okay, so if 3 marks, you can test the gas also, right? Okay, beside you use a magnesium ribbon, use the metal, right? Reactive metal like zinc, magnesium. Okay, so beside the metal, what else you can use? Another one. Calcium carbonate, the metal carbonate, yes. Then you get the same observation, effervescence occur or colorless bubble gas release. Okay, good. So add in magnesium powder into the R. This is action, remember. When chemical test, action. Okay, then observation. Colorless gas produce pop sound. Okay, this is the observation. Okay, when tested with burning wooden splinter. Okay, if you want to use the add in calcium carbonate into, okay, add in calcium carbonate into the R, and then calcium colorless bubble gas that turns the lime water cloudy when tested with the lime water. Okay. If can, you don't use the word test, you do the action again, even better. But here 2 marks only should be no problem. Okay, huh? Next, this is a graphite. Okay, graphene sheet here. So it is one of the carbon allotropes, and it is the most reactive carbon allotropes. Name the other allotropes of carbon. So what is the answer? Besides graphene. Graphene, graphite. Okay, or diamond. Yes. Okay. Anyone? State the physical property of this graphene. What is the physical property? Hard, one atom thick. Okay, any other answer? Okay. Physical property. Okay, hard and strong, transparent. Okay, good heat and electrical conductivity, elastic and flexible, impermeable, very low electrical resistance. Okay, any one. Okay. Marcel, one atom thick. One atom thick we cannot see. Physical property is something we can see, we can observe. Okay. Okay. Now, okay, for this diagram shows the structural formula for compound J and K. J and K. J is a homologous series. So J, what is a homologous series class? Alkene. K. You have this one is a carbon-carbon double bond. This one is a OH, alcohol. Good, 2 marks. And name the compound K. Butanol, butanol. Okay, butanol. But you need to mention it based on the IUPAC nomenclature. Where is the hydroxyl? Butane, 2O. You have to mention this one. Marcel? Okay, name the reaction. Alkene to alcohol. Hydration, hydration. Okay, good. What is the condition? Here, not us, not us in you, the condition. What is the condition for hydration? What is the catalyst used? And then, what is the temperature? 300. Okay, catalyst for hydration. Steam. Steam is the water, right? Phosphoric acid. Phosphoric acid, you have to mention concentrated, concentrated phosphoric acid. Okay, so remember. Okay, now draw another isomer for the compound K and name it according to IUPAC nomenclature. So what is the name? Another isomer for compound K. Butane 1O is that butane 1O. Butane 1O structure and then name. Okay. This one, you can put it at this one here or here or here, as long as carbon number 1. Okay, carbon 1. Okay. Now, how is produced an acidic dichromatic solution is added to the test tube containing the K. Okay. Acidified potassium dichromatic. What is the color for this? What is the color? Yes, it's orange. Initially. Okay. Now state the observation. So initially orange, what it will change to? Orange change to green. Yes, orange to green. And write the molecular formula for L. Is produced when you produce it from the alcohol, right? Butanol, butane 2O. So what is your compound L? The molecular formula will be butanoic acid, right? Butanoic acid. Okay, CH3COOH. Okay, butanoic acid. for carbon, for carbon. Okay, now compound J burns completely in excess oxygen. So chemical equation for the complete combustion, J. So it'll be butene, oxygen, carbon dioxide, and water. Oh. Next comes the area executions. Okay, question number 9, question number 10. There are 2 questions, right? Okay, you can answer both, okay, if you have time, but you choose to answer 1 question first. Okay, and section C, another question. Then if you still have time, then you can choose to answer the other one. Okay, don't choose to answer both questions first. Okay, later you don't have time. Oh. Okay, now question number 9. So this is rate of reaction. Based on the diagrams, salt in which glass will dissolve faster? Okay. Cold water, hot water. So which one will dissolve faster? Let's put the answer. All right. Okay. And normally we'll use glass. Here don't mention it. So you put hot water. Hot water. Salt in hot water. So explain the answer. Hot water has higher temperature and heat energy. Higher temperature increase the reaction rate, or increase the rate of dissolve the salt, right? Okay. Okay. So number 2, set number 2. Wait, okay, we go back here. And rate of collisions between the salt particles and the water molecules. Rate of collision. You can write. Okay, Marcel, you can write it because it's not wrong. Because 3 marks, you can write something. You can, because it's your point is correct. So you don't worry. You wrong cancel right. Okay, now B. Set number 2. Set number 2 here 100. Okay, here the English version. This one is 1.0. I'd like you to do the correction here. 1.0. 1.0, not 10. 10 will be too much. We follow the BM version. 1.0. Okay. So set number 3. Okay. Later you will see, it will ask you to compare 1 and 2. Okay, 1 and 2 you will compare, and then 1 and 3. Okay, you will ask you to compare. Okay, now if 1 and 2, what is the factor affecting the rate of reaction? 1 and 2. Concentration of sulfuric acid. This one 0.5, this one 1.0. Same concentration, same temperature. Okay, then how about 1 and 3? 1 and 3, same concentration, but different temperature. So this one will be a concentration. 1 and 3 will be temperature. Okay, Okay, now state all factors that affect the rate of reaction in experiments. 2 and 3, 1, this one should be 1, 1, 2, and 3. Factor in concentration of the reactant solution, there is an acid, and then the temperature, 2 factor. Okay, now write the chemical equations and then calculate the volume. This one I'd like you to try. Write the chemical equation and try to calculate the volume of gas released. Okay, Marcel. Nice. Okay, so I already get the answer. So first, chemical equation list. So this one, mark that. So this so for calculation that 0.05 for sulfuric acid. So more is 1 to 1. Okay, one more of sulfuric acid, one more of hydrogen gas. So 1. So more will be the same, 0.05. No, this one should be no, not the hydrochloric acid. That should be sulfuric acid. No? Then this is hydrogen. So to be same, 0.05. So okay, 1.2. 1.2 with 1.2 repeat that. Okay, now compare the rate of reaction based on the collision theory, using the collision theory. Experiment 1 and 2, actually, experiment 1 and 3, so 10 marks. Okay, so this one, have you finished trying this? Shannon? Marcel already, huh? Tokyo, how about you? Finish also? Yes, huh? Okay. Felix and Shannon? Yes, huh? Okay, good. Then we can discuss directly now. Okay, 1 and 2. Okay, 1 and 2. So it's a factor of concentration, right? Okay. So first you can write rate of reaction in the experiment 2 is higher than experiment 1. Okay, so I hope all of you have noticed that rate must be higher or lower. Oh, it's up to you. You want to mention the experiment be lower. Okay. This one you can put at the point and also can. And the concentration of sulfuric acid in experiment 2 is higher than experiment 1. The number of hydrogen ions per unit volume, this one you have to, in experiment 2 is higher than experiment 1. Okay. The frequency of collisions between the here I think got mistake. Zinc atom, zinc atom. So it must be mentioned properly. Zinc atom and check zinc atoms. Okay. Zinc atom and hydrogen ion. You must mention the particle except the calcium carbonate. Calcium carbonate no need to mention. Atom, molecule, or ion, or calcium carbonate only. Okay. Next, frequency of the effective collision. Here is the effective collision. Zinc atoms and hydrogen ions. This one you can write particles. Okay, but I will suggest you just copy of the experiment 2 is higher than experiment 1. Okay, so 5 marks, 5 marks. So 1, 2, 3, if this one come up in the this question very easy to score. Okay, next 1 and 3. The reaction in experiment 3 is 1. Sulfuric acid in experiment 3. Temperature of experiment 3 is higher than experiment 2. Okay, next. Okay, one will be okay, kinetic energy of the hydrogen ions in experiment 3 is higher than experiment 1, or hydrogen ions move faster than experiment 1. Okay, so we mentioned about the kinetic energy of and frequency of collisions. between atom and hydrogen ions is higher than experiment 1. Okay. Then frequency of effective collisions. Okay, between zinc atom and hydrogen ion. In experiment 3 is higher than experiment 1. Yeah, I think. Okay, any question? Hello? Okay, now question number 10. Question number 10. Okay, so this one electrolysis of 0.0001 mole per cubic decimeter white chloride. Okay, so this one is dilute, no? Dilute. So if you see chloride, okay, so it's dilute problem, but if it is concentrated, then it will affect all. Okay, now it suggests white chloride. Write half equation for the reaction occur if the solution is replaced with 1 mole per cubic decimeter. White chloride solution, state the product at the anode, and then give you a reason. How about this question? Have you tried? Oh, okay. So given to you, there is small question at the back. Yeah. Okay, given to you the half cell equation, chloride. If this are given to you, it's very easy later on because it will help you to write the half equation correctly. So chlorine to chloride. Okay, this is the discharge, right? So discharge you write to the left now. Okay, so this one to the right. Okay. So what do you think is the right? Okay, you choose sodium chloride is a good choice. Okay, so can I choose potassium chloride? Can I choose potassium chloride? Can. It's the one, sodium chloride. Not mention must give the name. So, just suggest something. Just you can use the name. Okay. Now, here the question asks, write the half equation for the reaction A naught. So A naught, what is the half equation? A naught. A naught means oxidation, oxidation, lost electrons. So A naught is the oxidation. So chloride and hydroxide, which one is selectively discharged? Hydroxide, hydroxide, because it is dilute, right? So this is a half equation. Reverse here, reverse. Discharge, right, from the ions to the neutral discharge. So if this one given to you, actually is helping you to write the correct one. Okay. Then if it is replaced by 1 mole per cubic decimeter, what do you think is you will change the anode there? The hydroxide no more discharge, right? You will change to chloride, right? It forms a chlorine. Means that now the discharge, the chloride ions will be selectively discharged. Okay, forms a chlorine. Okay, because the concentration of is higher than the hydroxide ions. Okay. Yeah. So this factor only affects the anode for chloride, bromide, and iodide only. These three, if the concentration is higher. Okay. Other like nitrate, fluoride, sulfate now, it won't affect also, even though the concentration is very high. Okay. Remember, only P. If the concentration is higher, then it will selectively discharge. Okay, clear? Okay, now B. Okay. So based on the diagram, state the electron that acts as a cathode in the cell A. So, so for this one class, A and B, A is the electrolytic cell or the vortex cell class. Which one is the vortex cell or chemical cell? So B, you see the magnesium and the copper, these two different electrodes. So this one is the chemical cell. Chemical cell. Okay, or vortex cell. Okay, then this one is the electrolytic cell. Okay, electrolytic cell, it needs a battery, right? It needs the battery. Then where is the battery? No battery. And this one becomes battery power. B becomes the battery to this. Okay, so magnesium and copper. So which one is the anode? Undergoes oxidation. Magnesium or copper? Magnesium one. So this one is anode. Anode, this one is the negative one, right? Okay. This one is positive one. This one is not. Okay. So which one acts as a cathode in cell A? E or Q? Cathode and here. So cathode here, this one is a positive one. Sorry. This one is the anode. For the electrolytic cell, cathode is negative. Cathode is negative. So Q is Q, negative. So meaning that you see here, some negative, right? So meaning that this one negative connect to here. So this one becomes negative. This one is cathode, undergoes reduction. This one is a positive. Positive is a anode, oxidation. Anode. Any one of you is still confused of this? The name anode and cathode in the chemical cell and the electrolytic cell is reverse. Okay, but you just remember anode undergoes oxidation. Okay, for both, don't care it is electrolytic or chemical cell, anode must be undergoes oxidation. Cathode undergoes reduction. Okay. This one treatment for both. Okay, now explain the reaction at the cathode. Okay, your answers should include the following aspect. List of ion attract, then the selectively discharged ions, and then the reason why the ions is selectively discharged, type of reaction, and then observation. Okay, so I think this one I let you try 6 points. Try first, finish already, you let me know. Okay, now ready, class? Yeah. So we discuss. So first, ions that are present. And check here, we come copper and hydrogen. Oh, copper and hydrogen. Okay, copper and hydrogen ions. So which one will be selectively discharged, class? Copper or hydrogen? Copper, huh? But here you have to mention, you have to see the question. Name the selectively discharged ions. It should be the name copper 2 ion. Don't write formula. Huh? If you write formula, this point is gone already, missed already. The reason why the ion is selectively discharged. So what is the reason? What is the answer? It's the value for capital ions is more positive in value for the hydrogen, no? Not hydrogen, right? Okay. Hydrogen, right? Oh, good. And the type of reaction occur the cathode. Just now I mentioned to you, the cathode part is a reaction. Reduction. Okay, then what is opposite? Brown solid. Yeah, brown solid salt. Correct. Brown solid acid. Yes. Okay, huh? So the half equation will be like this. Although not asked in this question. So copper 2 ion gain 2 electrons of the copper. Oh, so reduction. Okay, now this here. This one transfer of electrons at the distance, right? Transfer of electrons at the distance. After a while, Eddie noticed that the carbon was not like, and then no change in the solution use. Okay, so here use the bromine and then iron 3 chloride, sulfuric acid. So identify the mistake made. What is the mistake, class? Both of these are oxidizing agent. Correct. Both of solution are oxidizing agents. Meaning that they will undergo a reduction. Huh? Why? Very simple. You just see bromine, it will change to bromide, right? 0 to -1. So reduction. Gain 2 electrons. So reduction, oxidizing agent. Then this one, iron 3. Okay, you change to iron 2. So you gain electrons also, reduction also. So both are reduction, as you cannot. So with the help of a Lambda diagram, suggest the modification that lead and mark the direction of the electrons flows. So suggested. Okay, so you can change it to iron 2 chloride. Okay, so this one. Okay, so if iron 2 chloride, right? Okay. Okay, now, after the modification was carried out, it was found that the carbanometer needle was deflated. Based on your answer, identify the oxidizing agent and reducing agent, state the observations at X and Y, write the half equations that occur at the X and Y, then write the ionic equation in MOV. Okay, so here, suggested we can directly discuss. So meaning that based on the modification, right? Okay, we have to follow this one. Okay, so oxidizing agent now is a bromine. Okay, this one maintain, right? Reducing agent will be iron 3 chloride. You can change to iron 2 chloride. You can change to iron 2 nitrate also can. It's up to you. Observation at X. So brown color, decolorized. For the bromine, you're decolorized. And while green solution turns to brown color, iron 2 to iron 3. This one is a bromine to bromide. This one is iron 2 to iron 3. Okay. The half equation, yeah, this one I showed to you already. Okay, so oxidation reduction. So ionic equation combine. This one 2 electrons, this one 1 electron. So this one times 2 overall. Then cancel the electrons, then combine 2. Okay. So 7 marks here. So you check, you check. Okay, ready? Now, last question, the section C. Okay, question 11. Okay, let's see. This is the short questions. Okay, very interesting one. Okay, diagram shows a reaction for salt Q. When salt Q is heated strongly, solid R is formed, which is brown in color when hot, yellow when cool down. So if you see this one, what is this, class? Lead-2 oxide, lead-2 oxide. So R, lead-2 oxide. So this one you can write here. Okay. The reaction of solid R and dilute nitric acid produce solution X. Okay. So class, have a look here. Lead-2 oxide and then colorless gas. Only one gas is released. So what is this? When we talk about when you heat the salt, right? There are 2 possibilities only. Nitrate salt and carbonate salt. Okay, so if only one type of gas is released, so what is carbon dioxide? Okay, if 2 gases will be nitrogen dioxide and then the oxygen. If there are 2 here, but here only 1, we know it's a carbon dioxide. So meaning that Q will be if carbon dioxide, meaning that R will be lead-2 carbonate. Okay. If nitrate, there are 2 types of gases released. Okay, then R is a lead-2 oxide. Lead-2 oxide. With nitric acid, it produces a solution X. So what is solution X here? That's if nitric acid. Lead-2 nitrate, lead-2 nitrate. Okay. And water normally not to write. We focus to lead-2 nitrate. So here lead-2 nitrate with the sodium carbonate. So it forms a precipitate Y. So what is this precipitate Y? Lead-2 carbonate. Lead-2 carbonate. Solution Z. The solution 1, sodium nitrate. Okay. So if you know this, then this question becomes very simple on me. Very simple. Okay, let's see what is the question. Set the name of W, turns the lime water here. So it is carbon dioxide, right? Okay. identify the salt Q, R, and solution X. So lead-2 carbonate, R will be lead-2 oxide, X will be lead-2 nitrate. This one must be named. These three you can use the formula. Okay, because here define no problem. Okay. So 4 marks. This time, any question? Huh? Any question you are not sure? Felix, Shannon, okay or not? And okay, now describe briefly a chemical test to verify the N ion in the solution Y. So let's see. In solution Y, Y lead-2 nitrate, no, nitrate. Okay. So nitrate ion. So what is the test class? We want to test it. We use the brown ring test, right? Brown ring test. You need to there are three chemicals, right? Three chemicals you need to use. Yeah. So pour solution. Test it. Test it. Well, normally we don't say pour. We can say egg. Pour like a lot of solution. Okay. Diagram again. This one, huh? Is it this one? Why is carbonate? Wait. Yes, because here you see sodium carbonate, lead. So lead carbonate. Then the other one is the sodium nitrate. Hey, why? Let me see. Oh, you are correct. Okay. Let me see. Solution Y. Why got solution Y now? Should be Z. Why solution Y? Nitrate. Nitrate. Should be Z. Sorry. I think solution is X. Sorry. X. Not Y. Okay. So solution X, not Y. If so, Y it will be the solution. If solution, no need. Okay. If carbonate, right? If the question asks you this one, the precipitate Y, okay, is lead-2 carbonate. So it cannot be the one. You have to heat this one and then bubbles the gas release to the lime water. Okay. And then it turns the lime water to cloudy. Okay. But I think this question, its purpose is ask you to verify the nitrate ions. It should be X. It should be X, not Y. Okay, not? If it asks you to carbonate, it asks you to verify the carbonate ions. For the Y, it is not possible. Okay, because it is lead carbonate. If lead carbonate, it won't be able to form the carbonate ions because it is not soluble in water. Okay, or not? So question, I think the typing error should be X. No, should be X. Okay, so X solution Y should be X. Should be X. Into the test tubes and then add sulfuric acid. Okay, into in correction test. So add in sulfuric acid, dilute sulfuric acid, iron 2 sulfate solution, okay, into plastic, into plastic. Okay, then carefully add in the concentrated sulfuric acid. I mentioned you slant the test first, and then carefully add in the concentrated few drops, and then brown ring, okay, you form the brown ring. Okay, if can, okay, you put in the to be safe, okay, this one you aim 2 cubic centimeter. Okay, this one also 2 cubic centimeter. This one also 2 cubic centimeter. Okay, this one a few drops. Okay, to be safe. Okay, because sometimes the answer scheme ask you change the volume. Okay, so you knock down, you knock down. It's an inch. Okay, corrected one. Okay, later we put in the volume. Okay, like this. Okay, you form the brown ring. Brown ring. Okay. Okay, so are present. Okay, now B1 suggests the name for the reaction that occur between the solution Y and sodium carbonate solution should be solution X, all right. Right, the chemical equation. So this one is called what? Double decomposition or precipitation. Okay, so the equation. Okay, so class in the exam you have to be careful if the chemical equation are this one. If ionic equation, you're not asking, I just question is the ionic equation. What is that? We focus to the insoluble, that is the lead carbonate. The lead ions, carbonate ions. Very simple. So this is the ionic equation. Okay, now we focus to the insoluble, the solid one. So we got the aqueous solution, the solution one. Okay, huh? Okay, now one of the salt produced from the reaction in the one is also found in a sandwich that in school. His sandwich contained the processed meats such as the sausage and salami. Okay, so this salt is added to the sausage and Okay, preservative agent that inhibits the growth of bacteria that spoil the color. So what is the salt? Sodium nitrate. Okay, the process can salt dissolve in water. Yes, it is dissolved in water. Can be sodium nitrate. Okay, or sodium nitrate now. Okay, also can. Okay, now, this briefly how to separate the naphthalene. Two white solids, right? Two white solids. Naphthalene and magnesium chloride. Okay, so how to separate naphthalene from the magnesium chloride? Explain the differences in the observation after the mixture is separated. Interesting, huh? So class, discuss first how to separate these two. You do this. Add water, huh? Add water first. Filter directly cannot because both are solid. Okay, so in this still the mixture first. Then mixture with the glass rod. Filter the mixture with filter funnel and the filter pepper. Why? Because magnesium is soluble in water, right? Then it is soluble. Then naphthalene is insoluble in water. Okay. And magnesium ion is attracted to oxygen atom of water molecule. Is negatively charged, while chloride ions attracted to hydrogen ion water molecule, which is positively charged. A strong electrostatic force exists between the atoms of molecule and the ions of magnesium chloride. Okay. Then naphthalene is not soluble in water. Naphthalene molecule is neutral. It does not have any charge. No force of attraction exists between the atoms of water molecule and naphthalene molecule. Is the suggested answer. Let me double check again. Difference. Okay, you need to explain these two. Okay, so here explain why the ion compound is soluble in water. Okay, here explain why covalent compound cannot soluble in water. Okay, for me these two points is not that popular in the SPM. Okay, just for your extra information only.